Designing and validation of a sprocket wheel for a Formula student vehicle. Abstract. This report includes the overall design process and analysis parts of a part of the powertrain/drivetrain component of a vehicle called as a sprocket. The process consists of designing a part using the accurate and precise CAD software followed by elimination of defects and optimization of the part. The validation of a part is carried out on the basis of analytical study performed by the CAE software. The part is a component manufactured for the Formula student car of Team Hermes Racing of KIIT University. It has been designed to perform effortlessly in all the dynamic conditions and consists of the capability of being tuned manually to enhance the car's performance according to the requirements of a specific dynamic event. A 45-teeth sprocket has been chosen here as per the requirements of the car. Keywords: sprocket, Formula student, CAD, CAE, billet, pitch circle diameter. A. Introduction 1.1. Background. 1.2 Sprocket billet. 1.3 Roller chain. 1.4 Design and performance requirements. A sprocket is a categorical type of wheel with multiple teeth/slots that can mesh with a chain and get attached with it. Sprocket, namely, refers to a wheel of any type over which radially directed projections for engagement is made and a chain is passed over it. It is differentiated from a gear by the fact that it can never be meshed together directly and differs from a pulley as a sprocket has teeth. Sprockets find applications in bicycles, motorbikes, cars, tracking vehicles, and other machinery, either to transmit rotational motion between two shafts where gears are unsuitable or used to impart linear motion for tracking, taping, etc. Usually sprocket is found in bicycle, where the pedal shifter carries the large sprocket, which acts as driver of chain, furthers a driving sprocket of the rear wheel. Automobiles in the past largely used sprocket and chain mechanism. Sprockets bear various types of designs. Sprocket wheels and chain are typically used for transmission of power from one shaft to another from where a restriction of slippage is present. Sprockets are designed to bear heavy torque and resistance to fatigue load. A sprocket billet is used to support the sprocket and assemble it with the drive shafts and the differential used. It has drilled holes as per the pitch of the sprocket. The holes of the sprocket billet must have the same number of drilled holes and the same pitch as that of the designed sprocket wheel. The pitch circle diameter of the billet should be made complementary to the sprocket. The billet needs to have splines which can bear one of the ends of a differential and the other end of a half shaft. It can be manufactured using several materials as well as several advanced manufacturing techniques such as water jet machining. Roller chain/bush roller chain is a categorical part of chain drive mechanism used commonly for transmission purpose of mechanical power to versatile machineries, including conveyors belts, tube wire machines, printing presses, automobiles, motorcycles/bicycles. Short cylindrical roller cells compile up together to hold together by side links. A toothed wheel called sprocket is used to hold the chain and connected within the driven and driving sprocket. It is meant for simple and hassle-free power transmission. The sprocket has been designed as per the use and performance required by a Formula student vehicle. The preferred parameters are as follows. Vehicle performance plays a major role in the dynamic conditions, thus the sprocket used here has been designed in such a manner that it can provide the maximum efficiency. The sprocket is designed to bear the load of a 390 cubic capacity, cc, engine and 42 brake horsepower, bhp. The sprocket needs to provide high acceleration to the vehicle along with the maximum torque it can. The utmost optimization in the sprocket is needed to be done so as to obtain maximum acceleration and higher rotations per minute, RPM, of the wheel, thus providing higher speed to the car built. B. Literature Survey 2.1. Constraints and Considerations 2.1.1. Overall dimensions should be compatible with the rear end packaging of the car. 2.1.2 The number of teeth defines the level of reduction, hence deciding the output characteristics. 2.2 Material selection 2.2.1. Reasons for using aluminium 7075 tempered alloy. 2.2.2 Mechanical properties. Sprocket mainly interlinks with the differential and the drive chain. Size of the tooth count of the sprocket is the main factor influencing the acceleration of the car and transitions between the gears of the transmission during dynamic events. Sprocket is built to take the linear force of the drive chain and produce rotational energy from it to rotate the differential further connected to the wheels. Thus, the diameter of the sprocket helps to produce a moment arm to produce a torque on the differential. Here, a 45-teeth sprocket is considered because using such a sprocket will result in better start in the acceleration. The main objectives during the designing of a sprocket are to make sprocket lighter and optimized for larger moment arm. Sprocket is the final element of the driveline where reduction occurs, so design of the sprocket should be such that the rate of acceleration and output torque should be decent and one should not be compromised for the other. The sprocket is manufactured using aluminium alloy 7075 which is tempered, thus, bearing the grade of aluminium T7. The composition of the alloy chosen is 5.6–6.1% Zn, 2.1 to 2.5% Mg, 1.2 to 1.6% Cu, and about 0.5% of iron, silicon, chromium, titanium, molybdenum and other metals. Some other tempers are 7070 T6, 7075 T651, 7000, and 7420. The material is preferred due to its high physical strength, fatigue strength, good Mach-inability and lightweight nature. Bears an elongation failure of 13%. T7 tempering involves overaging the material in raw state. Aging is done at 100 to 120 degrees Celsius for hours and then at 160 to 180 degrees Celsius for around 24 hours. T7 tempering produces a microstructure of mostly ETA precipitates, Ni3Ti. As compared to temper T6, the precipitate particles of T7 are larger and oriented to growth. Thus, the susceptibility to stress corrosion cracking is reduced. Table 1. Material properties. Properties. Metric. Tensile strength. 510 MPa. Yield strength. 410 MPa. Elasticity of modulus. 70 GPa. Shear modulus. 26 GPa. Poisson's ratio. 0.32. See calculation. Acceleration for sprocket with 45 teeth. Given. Torque equals 35 nanometers. First gear ratio equals 12/30 seconds. Final drive ratio equals 2.66x 2.66x, 45/14. No of teeth in driven sprocket equals 45. No of teeth in driving sprocket equals 14. Assumed driveline efficiency equals 60% equals 0.6. Rolling radius of wheels equals 0.228 m. Vehicle gross weight equals 220 kilograms. Acceleration thrust equals torque x final drive ratio x driveline efficiency, I. Rolling radius of wheels equals 35x 2.66x 2.66x 3x 0.6 equals 1955.1 kg.m/s2. 228. Acceleration rate equals 3.1. Design alternatives. 3.2 Design determination of the sprocket. Acceleration thrust, 2. Vehicle gross weight equals 19,551 equals 8.88 m/sec2. 220. Table 2, acceleration on the basis of number of teeth. No. Of. Acceleration. As per the formulas provided in the table, 3, the values required for designing a sprocket wheel are determined. The chain used for reference is that of KTM RC390 motorbike. The determined formula for the required values is as follows. Table 3, Formulae for designing of sprocket. With the data from the table we can proceed forward for the stepwise designing of a sprocket. 1. All the values required were derived as mentioned in table 3. 2. A pitch circle of radius 1/2 of PD was drawn. 3. Construction line 1,2 was drawn from center of circle to top quadrant. 4. Horizontal line 3,4 was drawn from top quadrant and tangent to pitch circle was made. 5. A circle with radius r, at intersection of 1, 2 and 3, 4 was drawn. 6. Offsetting the above lines was done. 7. Extending line CX was made. 8. Line psi was drawn equals E. 9. Draw arc XY and line segment YZ. 10. Locate offset point made above and make a new circle radius F. 11. Joining the tip of lines were made and required shape was given. 12. Follow up trimmings and others to get the proper shape. 13. Mirror of the above line and arc was done to get the desired drawing. 14. Array the tooth with the pitch line of the wheel. Here we have used 45 teeth, thus array it 45 times to get the required sprocket wheel. D. Result. A 45 teeth sprocket wheel was thus designed using the previously mentioned steps and with the following values of data calculated. E. Design validation. A design is ready to be applied practically, only if it is fit to undergo the various harsh stresses of nature. Thus, a proper analysis of the designed product is required to be done to validate its application. This can be done using any CAE software under suitable parameters. 5.1 Static Structure Analysis. A static structure analysis of the sprocket is done validating the material used and even the design. Following constraints have been provided. Total force applied 30 N, maximum torque applied at 6,000 rpm. Maximum deformation at red region equals 0.01739 mm. Minimum deformation equals 0 mm. Fig. 1, Static Structure Analysis. 5.2 Dynamic Analysis. For a sprocket, undergoing the extreme forces in dynamic conditions is a prime factor. Thus, a dynamic analysis validates it, with the following constraints provided. Maximum force applied equals 2000 N. Maximum deformation at dynamic condition, marked by arrow, equals 4.90*102 mm. Minimum deformation at dynamic condition, dark blue region, equals 1.00*101 mm. Fig. 2, Dynamic Analysis. 5.3 Analysis Results. FOS. Fig. 3, Determination Factor of Safety. From the above shown analysis result, the factor of safety of the sprocket can be determined. Thus, the maximum factor of safety of the design is 6 while the minimum is 2. This means that if double the force taken in context is applied, even then the design failure will not take place and yield point will be achieved once the magnitude of force goes beyond double the value of the force. The fracture point will be achieved once the force reaches at a magnitude of 6 times greater than the applied force. So, the factor of safety is under the limits, as directed by the rules of designing. F. Conclusion. The CAD modeling of a sprocket wheel was done by using DS SolidWorks software. The model was designed, keeping in mind all the rules, required constraints, and as per the application in a Formula student vehicle. The chain considered for the wheel is that of KTM RC 390 motorbike, because that is the engine used in the Formula student vehicle of which the reference has been taken. Further, the analysis of the sprocket wheel was done using apt CAE software, namely ANSI and DS SolidWorks. Analysis of the wheel was done in terms of static structure and under dynamic conditions. Factor of safety of the design is under pertained conditions. Thus, this validates the entire design and declares it fit for getting manufactured. G. References. 1. Documental repositories, Team Hermes Racing, KIIT University, Hermes Racing. In web link. 2. Machine Design, www.machinedesign.com web link. 3. Design Data Handbook, SMD Jalaluddin. H. Abbreviations used. 1. P equals chain pitch. 2. N equals number of teeth. 3. Dr equals roller diameter. 4. Ds equals seating curve diameter. 5 Rs equals seating curve radius. 6 E equals length of arc psi. 7 F equals radius of complementary small circle. 8 PD equals pitch diameter.